Okay, so what I'm going to do is just very quickly do a little bit of refactoring here. Get rid of some of this code that we don't really need, and then clean it up a little bit so that I can reuse this later. So first thing I want to do is create a function called GPIO or GPIO portf init, and is of course going to be void. We are going to put this up here, and then all of the stuff that we need to do here, I'm going to cut and put in here, and instead of this I'm going to call this one up here. So the first thing that we need to do is there we are. So we should have basically all of this functionality ready to use when we start doing things later. And I'm going to copy paste this, of course. So the next thing I want to do is I want to start to work with Systick, and I want to use the interrupt of Systick. So here's what I'm going to do. I'm going to say new project, new CCS project, and I'm going to say Systick interrupts. I'm going to continue to use this one, and then finish. So now we have our blank main file, and we have all this. So one of the things that I need to do is I need to add a file, and let me see if I can get it to import this file from a recent project. So import C or C++. Okay, it's kind of difficult to, maybe let's give this a try. Home source, basically just save a little time and not have it not have to copy this particular file. Okay, so basically this doesn't allow us to do any imports, which is not a problem. What I'm going to do is I'm going to just do a copy paste. So I'm going to do Control A, Control C, and then in this folder I'm just going to go say new file, new file in this folder, and I'm going to call it basically the same as this thing. So this is tm4c123 gh6pm.h, and then I'm just going to basically paste all this content in here. That's all. Naturally, of course, I expect that everything is going to build. Then next thing I want to do is now go into this old main.c. Something was a problem here. Oh, missed a semicolon here. So that's why the build here had failed. But anyway, I mean, everything else is hunky-dory. So I'm going to copy this portf function call out here. I'm going to copy the declaration up here. And the other thing that I need is I need these two, which also I'm going to copy up here. So that's pretty much all I need from the old project. Next thing I need to do is yeah, the rest pretty much I don't need. So now I'm going to go and close off this project, I'm going to say close project, and that's all. So now when I build, it only builds this particular project. So now what I need to do is, now I need to set up Systick, and I need to set up the interrupts. Okay, so first thing we need to do is set up Systick. So let's go and do that. Okay, so I need to figure out what the Systick registers are. Okay, so again, we need to go to the data sheet, which is our folder over here. So we need to go to the TRM, because of course the TRM is the architecture reference manual, and Systick is part of the ARM Cortex architecture. So Systick. Okay, so this is our Systick. Actually, maybe Systick is covered earlier. So let's go look for it. So these are the registers here, STCR and STCSR and so on. But these are not described here. So it says very clearly, registers not described here are described in the ARM v7m architecture reference manual. So this is not the one we should be looking at. Let's go and see the architecture reference manual, or the generic manual also. Sorry, was that the one we were using? No. So we want to get into this. Okay, so let's see if where are we? This is exception model. There we go. So the system timer is explained here. So this is where in the M4 devices user manual, this is where the things are, Systick details are given. So now Systick status and control register, this is what we need to basically modify or write to in order to be able to do stuff. Okay, so the first thing is, what is the address of this we have to find out, and then what is it that we need to write to this. So we need to write a 1 here to enable the Systick. We need to enable, so this is where we'll see the bit fields. So enable has to be written to 1, which means we have to enable the counter. We have to enable the interrupt, which we'll do later, and then we have to enable the clock source, which means we want this processor clock to be active. So we need to enable the system timer, and we need to write 101 to this, initially at least. So system CSR, let's go back to our program here, and let's talk about what we need to do. Enable Systick. So what all do we need to do here? So we need to write hex 0 1 0 1 0 1 0 1. That is what we need to write to this, and this value is basically 5. Okay, so 1 2 4, right? So that's why 5. So hex 5 needs to be written into this register. So let's figure out what is the this is what control and Systick control and status register. Okay, so this is certainly exists in our header file. So let's go and find it. Okay, let's go and find this. Okay, so Systick is up here, clear pending. This is our pending interrupts. This is exception priority, Systick exception, Systick exception. Okay, so maybe it's not called Systick, maybe it is called what we just saw here. So let's see. Okay, that is also not the case. It's not called control and status. Let's look for system timer. Okay, let's look just for timer. So we find watchdog timer. So these are all, actually let's start from the beginning. So starting from the beginning, watchdog, timer 0, timer 1, timer 2, timer 3, timer 4, timer 5. These are all the other timers. So there we go. These are watchdog timers. Then timer registers for timer 0. Then we have timer 1, timer 2, timer 3, timer 4, timer 5. I'm not sure what W timer, maybe watchdog timer 0 and maybe watchdog, I don't remember. Then let's see if there's anything else. W timer 2, W timer 4, W timer 5. Okay. So this is where we will probably find our Systick timer. Maybe it is SR timer? No, probably not. Let's see, where would it? This is DMA. This is your watchdog related. These are port A, port B. It's unlikely that they should be so far down. Let's check. SSIO. This is DMA. By the way, this QEI stands for quadrature encoder input. So timer 0, timer 0 CFG. It's unlikely that we won't find it fairly quickly. So these are all these timer match. ADC. And you can see this is a fairly large file. I mean, we are already at 5,000 lines. So it's not like it's just too easy to find things, but it's not impossible either. So all of these are ADC related things. Not much to find here. This is our RTC. This is again watchdog related. Timers, again timer 0, timer 1, watchdog 1, 2, 3, timer 0. And clock gating control. It's unlikely that it will be this far down in the file. So maybe we are not looking at the correct thing. Okay, let's just check. Okay, so it turns out that the timer registers for Systick, the Systick is part of the core, and because of that, all of those are defined under the NVIC. So if you go under NVIC, you will find under NVIC there is NVIC underscore, there you go, system timer, control register, reload and current value. Okay, so we need to copy off these values. So what do we have to do? We have to write hex 5 to this. Okay, so again, right now it's okay to write 5, but what we should ideally do is, for example, this ST CTR CTRL, right? So we should go and find the correct bit fields for this and then and then write it correctly. Okay, so they have not defined the bit fields. If we want to do it, we should do it at a later point. So anyway, we'll stick with this for now. The next thing to do, this is the control and status register, which we have already written to. Reload value is what tells us what is the value to which it gets reloaded. So we need to write the correct value to the reload register. So what would be the reload register? That is this one, fairly straightforward. So we are going to go and reload a value, let's say uh, hex 10. So hex 10 is going to be 16 in decimal, and then let's put a while one at the end because we don't want our code exiting anywhere. So this is basically our timer setup, and we also want to basically make sure that we start from some known value. So we also want to set this current register. You just want to write it to some known or some sane value. So I'm going to write it like this. And in fact, I should do this in exactly the opposite order, in the sense that I should load the reload value and current value first, and then I should start the timer off, so that I know that the moment I start it off, it will start from some reasonable value. So let's go and see whether this indeed is how things happen. So let's build, and then we go into debug. So I have my board connected. Of course, there's nothing to see on the board, so I'm not using, I'm not really going to the board, but I can show you the board if you want to see that it's actually connected. So anyway, so let's do a step through of this program. So the first reload register got written. Let's view our registers as well. So view registers. So under our core registers, if we recall that, sorry, not core registers, under NVIC registers, we should find our, so here's our NVIC, and under NVIC, we'll find all these. So the first thing that we did was we wrote 10 to the reload register, so that got written. Then the next step was to write current register got 0, so that is done. Okay, so now the next step is to see whether this actually happens. So now let us step in. So now our STCTRL, which is our timer control register, is now loaded with 5, which means that the clock is enabled. So now let's go and see the current value. So now the current value should get loaded, and then things should start running. So there you go. So now the value got loaded and it started decrementing. So now I'm going to do single step. So 9, of course these are not single step instructions, that is why it takes single clock cycle for per instruction, that's why it decrements by more than 1, and there you go. So it keeps decrementing, and then when it reaches 0, you can see that it goes back to hex 10 and then it comes down. So that means our timer is working, it is decrementing, everything is done. Okay, so that is working. So incidentally, while since you've got this working, let's just go back to Git and let's see how to add all of this into our into our repository. So first thing to do is I want to see, I seem to have made some changes to this main.c, so let's go and add those changes in. I want to see what the changes are, so I'm going to do git diff blink-main.c. So you can see that basically there are some line endings have changed. That is one problem, and the other one, of course, is the fact that I refactored this into a GPIO external function. Okay, so I'm going to do git add -u, which basically means that I updated this file, and I'm going to commit this one. So refactor and since this is done, I want to push it up upstream. Git push to where to getty. That's it. So that's done. So now I need to start adding things for this project. So git status cd Systick interrupts. Now we need to start adding. So what all do we add? So git add star.c, all the C files I need to add. So I've added these two, startup as well as this main.c. I also need to add .c project. Okay, so so now CCS project and .c project both have been added. I also need to add this .project file. Also need to add the settings. I also need to add target configurations. I also need to add these two. So basically now all these files have been added, and I can do git commit. Now this is added, and I can push this up. Right. So now this is done. So the next thing is, now I have to make this work with interrupts. So what does it mean? First of all, I need to, right. So now the next thing that has to be done is to get this to do interrupts. Okay. So the first thing we need to do is we need to change this bit to a 1, which means the interrupt enable bit has to be set, which means this has to be 7, which means this has to be 7. Okay, so now I know that every time the timer reaches 0, an interrupt is going to be generated, and when the interrupt is generated, I want to do something. Okay, so what should we do? So then we can say, okay, let's toggle some LED or something like that. So to do that, let's call our GPIO port f init. So now our port is initialized right at the beginning. Then NVIC setup is done, and then we'll just continue to wait till the timer runs out. Now, because the interrupt has been enabled, I need to create a function handler that tells that basically contains the code which will be executed every time. So obviously this function must always be a void function because you can't pass parameters to it. So it will be Systick handler, and you can't pass parameters, so it's going to be, obviously it's going to be void function, right? And for correct compilation, we need to, oh sorry, didn't need to do that. We need to put the declaration right up here at the top. Okay, and then to make sure that this function gets called indeed, what I need to do is I need to go out here and I need to say that this function should be called when Systick is interrupt is triggered. So where is our Systick interrupt? That was up here. That was SV call and then Systick handler. So I'm going to replace this with my Systick handler. Okay, so let's try and figure out. First of all, let's see if this builds. Okay, this won't build because this is undefined. Okay, and why is this undefined? It's undefined because this particular C file has no idea what this is supposed to mean. Okay, so what we are going to do is we are going to just copy this function and then we are going to stick it up here in the top, and that's it. Okay, so now let's try building this. So now build is done and everything is done. So technically, like I mentioned in the last class, my understanding was that uh, to be uh, say to be absolutely correct about this, we should declare this as extern. So you can notice that as far as I can tell, um, oh sorry, save and build. So when we build this, we are really not getting any issues. So it's able to figure out that okay, this particular function is declared somewhere else, and then it's going to get linked in. So that's fine. Question is, what do I want to do in this Systick handler? What I want to do in Systick handler is basically toggle an LED. So let's see if we can toggle an LED. So um, what would be a good way to uh, toggle an LED? So let's say we can put a statement like this. Okay, so which means you take the port F data and then you XOR it with hex 2, which basically means that the pin that is corresponding to the red LED will get turned on and off and on and off and so on. So let's see if this builds. It should not be a problem. Everything builds. Let's try and debug this. There we are. So now what should happen is let's single step through this. So this is where our timer is going to get set up. Okay, so you can see the timer got set up. Let's go and see what's happening on the NVIC. So NVIC, there we are. These are the timers that we need to watch out for. Okay, so we have not yet enabled uh, the uh, the control register. Okay, so now it is enabled. So you can see that this became 7, which means all ones. Now our timer started from 10 and started decrementing. So by the way, 10 is 16 in hex, and so 16 minus 4 is 16 minus 4 is 12, which is D. Okay, so that's where we are. 5 1, and now the next cycle we should end up inside our interrupt. So let's see whether that happens. That happened. However, we have not ended up in our interrupt. We are still sitting in our while loop. So now the question is, why did that happen? Let's just see. It could be, is it just a problem of this interrupt, sorry, the timer count being too low? Probably not, but let's just double check. So let's make this slightly higher, build again, and stop debugging and then restart. Right. So now to figure out why this is not working, which is really the objective of this course, is to figure out why things don't work and how to make them work. Right. So let's do this single stepping again. So we have done this port F init is done. Then we have enabled this. Now NVIC is the Systick is enabled. There's a 1 here. Now let's see, assembly step into, and let's see what is going on. So where is our timer? So our timer is up here. So now it's decrementing. So everything seems to be working fine. Everything is working fine. So let's do one thing. Let's go and put we'll put a breakpoint right here. Okay, so basically it should keep running, and if the Systick handler gets called, then we should end up here. Okay, so there we go. So we ran it and we ended up in this. We ran it, we ended up in this. You can see that this LED has come on. Okay, so next time when I run this, the LED goes off, goes on, goes off, and so on and so forth. So let me temporarily disable this breakpoint, and let's run this. Okay, so it seems that this value is too high and we can't see this because it's actually doing on and off. Let me put a breakpoint here. You'll see that it hits this, but the value is too high. So let's go and fix that. So instead of this, let me put a slightly higher value, and I'm going to pull this value out of thin air seemingly for now, but just so this value I'm going to make it hex 900, and this is the advantage of having a debugger, and you don't have to reload your program and do everything again, right? So let's see whether, so that's happening. So now toggle this breakpoint, let's run this. So once again it appears that this is way too fast. So let's see what is going on. Maybe let's see if we can slow this down a little bit. Okay, so let's terminate this. What's a reasonable value to use? Let's say we want okay, what we'll do is we'll put a little more delay. Okay, so what I'm going to do is I'm going to add another global variable called Systick count. Okay, so I don't want to turn this LED on every iteration. Uh, I want to turn it on every time this Systick count basically overflows. Okay, so this is an 8-bit counter. So if I start it from 1, every time I increment it, let me change this to this way. So my Systick count is going to get incremented every time, and if Systick count becomes 0, which means every 256 iterations of this being called, I will toggle my pin. So let's see if this will give us a visible pulse on our board. Okay, so let's see that. So we've got this working. Let's go and put a breakpoint here and run it. So we landed up in our interrupt routine, no problem. We keep landing up here, and you can see the Systick count is very much getting updated. So let me add variable. So how do I add a variable? Um, uh, there we go. So Systick handler is now, sorry, not Systick handler, our Systick count um, is unknown. Why is it unknown? So let me put, let's single step and check what is going on here. Okay, so Systick count is basically in this location. What is LDR? Okay, so I'm not sure why this is not showing us our variable. Um, okay, there we go. So we are able to get Systick count, and it's still at 4. Okay, so next time I do this, it should increment to 5 and 6 and so on and so forth. So okay, I don't care about this breakpoint being here. I've just disabled it. Let's run this, and now you can see that our board is giving us these flashes. Okay, so that is basically what is going on. And you can verify that what is the time that it is supposed to flash at by then counting how many cycles, the clock cycles, and all of that. So now 9C, I think 9C4 for this board or for this particular controller should give us 10 millisecond pulses. And what I need to do is, if Systick count reaches 100, then I'm going to make this Systick count equal to 0 and then start the game all over again. Okay, so build, and let's see, debug, and this should give me a 1 second uh, pulse rate. So I seem to have made some mistakes somewhere, because it is certainly uh, faster than this. So I believe that maybe sorry, maybe this is giving me um, a faster than 1 millisecond. So I think it could be uh, more than that. So let's do one thing. Let's stop this. Let's make our Systick counter, instead of uint8, let's make it uint32, and we load it with 1000. And let's see, because I think this is giving us a 1 millisecond. So if it's giving 1 millisecond delay, then we should do we should divide by 1000 to get uh, let's see if this works. There we go. So this gives us a much more reasonable, most likely nearly 1 second blink rate. So there you go. That is the uh, code that would give you your blinks. So we'll terminate this, and then just to complete the picture here, let's go and add all of this into our main file. And then git push. So that's about it.